Yes, so I was waiting for the call to be recorded. Try 10. And let me share the link here. Okay, thank you for your patience. Okay, more people are joining. Thanks for joining, guys. Thanks for joining. Let me share my screen so that we can start with our session. Okay. Hey, I haven't even done the thing here. Page templates. Let me just sort a few things, guys, then we shall begin soon. Today we are doing written probability. Yes. Okay, thanks for joining, guys. Written probability. Okay, page settings like this, and then filtrate. Okay. Without wasting any time, guys, let's get into it. I will do the thing there. What's it called this thing later? The first page, cover page thing. Actually, let me just do it written probability. Probability. Yes. Okay, I made a mistake there. Made a mistake. Probability. Okay. Okay. Thank you for your patience. The background. Uh-huh. What's happening? Okay. I'll fix the rest later, guys. Time is not on our side, and I heard that some of you are actually writing tomorrow. Best of luck to those of you who are actually writing. Anyway, let's get into it, guys. So, today we're gonna do probability. And I know, it's one of those topics that some of you guys may have challenge with. Maybe because I don't know, it uses a lot of English and a lot of big words, but it's really simple as we're gonna see today. It's really simple. Once you understand the whole idea behind a certain topic or a certain subject, it becomes easier to even understand. Like when I introduce functions and trigonometry, I was always stressing that okay, right now we're focusing on relationship between things. But now for probability, we're doing something a little bit different, a little bit different. Our concern right now is much chance, how much chance do we have? How much chance do we have of a certain thing happening? Of a certain thing happening. Let's say we had a sample of balls, blue balls. We can have blue balls, maybe 4 blue balls, and then we can have, let's say, 3 balls, 3 red balls, and then let's choose another color, maybe purple, and then two purple balls. And then let's say we were given a question that's how is it likely for you or for someone to pick a blue ball out of this sample. So how many balls do we have overall? We have nine balls, because it's four, three, seven, and two. That's nine balls. And then how much chance do we have of picking a blue ball in this sample? In this sample, how many blue balls do we have? We have four blue balls, and then how many balls in total do we have? We have nine balls. So this is the probability of picking a blue ball out of the sample. It's simply 4/9. And then if the question was how likely is for someone to pick a red ball out of the sample, you simply go back. So how many red balls do we have? We have three red balls out of nine. Out of nine. And then the same thing goes for purple. How much chance do we have of picking a purple ball out of this sample, out of this, say maybe it's a basket or something? How many purple balls do we have? We only have two purple balls over nine purple balls. So this is the probability, and you can see that purple has only like two balls. So, and it has like the smallest probability of happening. Okay, what does that tell us? As you can see that we have two balls, so we have less chances of picking a purple ball if we were to put a hand in this basket or in this plastic. Because there are very few purple balls. But if we were to put our hands there, put our hand there and try to pick a ball, we are more likely to pick a blue ball. Because why? Because there are many blue balls in that plastic or in that bag, in that bag. So that's why we are seeing that the probability of picking a blue ball is actually the highest over the three, and then followed by the probability of picking a red ball, out of that basket. So, guys, probability is all about how much chance do we have of something happening maybe over another, or how much chance do we have of something happening, So that is simply the probability. And then maybe what can also be asked, what is the probability of picking a blue ball, let's say a blue ball, blue or red? Blue or red, So right now we're trying to find out how much probability do we have of picking either a blue ball or a red ball, So how many blue and red balls do we have in this bag? We have seven blue and red balls, out of nine. We have 7 out of 9 balls. So that would be the probability of picking a blue ball or a red ball, if we were to put our hand in this bag and try to pick one ball from this sample, and then let's say maybe we are also asked what is the probability of picking a purple a purple ball or a blue ball, purple or a blue ball, and that would be what? This probability, this probability here of blue and this probability, we simply add those two probabilities because we are looking for the probability of picking a purple ball or a blue ball. So that will be actually how many purple balls do we have is two, and then how many blue balls do we have? It's four. So the probability of such an event happening will be 6/over 9. And then lastly, let's just also do red and purple. Red or purple. Red or purple. Red or purple. The probability of picking a red or a purple ball will be it's 4.
5/9.
Yes, it will be 5/9. Yes. Thanks for answering that. It will be 5/9. That's the probability of picking a red uh, or a purple ball. Because why? We have we have three red balls and then we have two purple balls. So if we add that together, we get what? Five. And then out of all these balls, the total is what? The total of all these balls is nine. Hence why we are getting a 5/9. Okay. And then maybe let me get something. Let me get something. Uh, just or maybe let me just draw it. I will add it later. Just to save time. just to save time, I wanna ask you guys something. So let's let's assume that this is a dice. Ah, and it's a bit too long. Hey, whatever it done. This is our dice. We have 1, 2, 3, 4, 5, 6, and then let's say maybe this side is what? I don't even remember how it dice look. Let's say it's 5 here. 1, 2, 3, 4, 5, and then let's say maybe here is 2. It's not perfect, but yes, we have this dice, and you know, uh, okay, that the dice has 6 sides. And then let's say the question was asked, what is the probability of rolling a 5 in a dice? You guys are familiar with it, as we have seen your dice. It has 6 sides. So I'm asking right now, what is the probability of rolling a 5? Rolling a 5. Rolling a 5. How many chances do we have to roll a 5 if you were to throw it right? If we were to throw a dice, you know, how much probability do we have of rolling a 5? Can someone answer it? Okay. I will assume that's okay. That's fine. Confuses you. I don't know if maybe you are scared to answer. If you are scared to answer or something, but this is actually a trick question. I know some of you were going to think that maybe since we're asking the probability of rolling a 5, it's gonna be 5/6, and then you will be actually incorrect with this, because out of 6 sides in the dice, only one side has a what? Has is a 5. Only one side is a 5. So the probability of rolling a 5 will be actually equal to 1/6. Over 6. Why do I say 6? And then let's say next one is rolling a 1. It's the same 1/6, because we only have one side that has a 1 in in a dice, and we only have one side that is a 5. Even the probability of rolling a 6, rolling a 6 will be what? Will be 1/6, because only one side is a 6 in a die. It's only this side. The rest of the other sides are what? Are 5, 4, 3, 2, and 1. So the probability of rolling a 6 will be 1/6. So the chances of rolling a 2 uh, will be 1/6, because only one side is a what you call this thing is a 2. Only one side is a 2. And then let's go ahead. Let's go ahead and then do something else. Let's go ahead and do something else. Let's say we are given a sample of what of numbers. Sample of numbers. 1, 2, 3, 4, 5, 6, 7, 8. I wanted to until 9. Okay, let's leave it like this until 8. So I give an example of 8 numbers. So and then the question is asked the probability of selecting an even number. An even number. If we were to select a number out of this sample at random, you know probability of selecting an even number, and then maybe let's do a prime number also. A prime number, probability of selecting a prime number. you know so out of this sample, or out of these numbers that we are given, how many of those are actually even numbers? We have the 2, the 4, the 6, and the 8. So it's 4 numbers. It's 4 numbers. It's 1, 2, 3, 4, so we have 4 even numbers out of a sample of what? Of 8, so the probability of selecting an even number will be what? 4/4/8, and then what is the probability of selecting a prime number? So the prime number, and remember, we exclude 1 from the prime numbers. So it's the prime numbers that we have is 2, 3, 2, 3, 5, and 7, so it's 1, 2, 3, 4. Oh, it's also 4, it's also 4. So it's 4/4/8. That's the probability of selecting a prime number, and maybe let's do something different and say a prime number or an even number or an even number, so we can either select a prime number or an even number. If we were to select a number from this sample randomly, we can either select a prime number or an even number. So what do? We simply add those numbers. So and then these numbers, they actually, okay, it's gonna be, okay, wait, what's happening here? Prime numbers, how many prime numbers do we have? It's 1, 2, 3, 4, and then even numbers is 2, 4, 6, 8. It's 4 also. How many numbers are here? It's 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. So the probability of okay. How come do we have, it's 2, 3 is a prime number, 5 is a prime number, 7 is a prime number, even number. Wait, something is confusing me here. It's 1, 2, 3, 4. So I'm trying to calculate the probability of a prime number or 1, 2, 4, 6, 8. What is happening here? But as you know, we see the probability of selecting either an even number or a prime number, we simply do what? We add those numbers. Oh, okay, now I see. We have numbers that are actually appearing twice here. Yeah, that was something that was confusing me, that it can't be 1 because 1 is also, we have that value that's excluded there. So let's just, to make things simple, let's just list the prime numbers that we have. The prime numbers, we'll list them in red. Is 2, 3, 5, 5, 7, and then let's list the even numbers that we have is 2, it's 4, it's 6, and it's 8, but we have this number that is appearing twice, so we're not going to count it twice, we're only going to count it once, so it's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So with 2 is appearing twice. So we're not gonna count it. We're not gonna count it twice. As I'm telling you, it appears twice. We're only gonna count it twice. So the probability of selecting a prime or an even number is gonna be 7/8. It's 7/8. That's the probability of selecting a prime or even number. Okay. So maybe another example that we can do, that we can actually do is, let me see. Before we even get into writing the question papers, I just wanna deck of cards. I just wanna do a quick example for you with the deck of cards. You all are familiar. Okay, I want one that's all. Okay, this one is fine. This one is fine. Download image. Mm, okay, let's come back here. Let's add an image. Let's add an image. Let's
Diagram
add.
dulu.
Video call.
Ah,
Yeah. Okay. So you guys all are familiar
Simple.
with the deck of cards. You know, a deck of cards has 52 cards. You know, it has 52 cards. Whoever just joined, please mute yourself so that we don't disturb other learners. Thank you. So excluding the jokers, you know, so uh we have what these trees, you know, the spades, the hearts, the diamonds,
aku mau
uh
grup kamu.
one,
American.
two, three, four. So we have 13 trees, you know, 13 trees, uh and we have 13 spades, we have 13 hearts, and then we have 13 diamonds, you know. So a deck of cards. All in all, a deck of cards has 52 cards, you know, excluding the jokers, just including the jack, the queen, and the king, you know. So it's 13, as I was telling you, that it's 13 trees, 13 spades, 13 hearts, uh 13 diamonds. So let's say the question was asked uh that what is the probability of selecting a red card? Red card. You know, if we were to pick a card randomly, so the probability of selecting a red card, you know, how many red cards do we have? Remember that we said it's each row has 13 cards, you know, so we have two rows, you know, so it's 13 plus 13, that is 26. 26 over 52 is equal to essentially 1 over 2. That's the probability that we have of selecting a red card if we were to select a card at random. Let's say maybe another question was asked, probability of selecting a spade, you know, a spade, just a spade, you know. So how many spades do we have? You know, we have 18 spades over the total number of cards. You know, the total number of cards, remember we said it's what? It's actually 52, you know. So we have 13 spades out of 52. That will be essentially 1 over 4. Another, let's say maybe um we ask to do a probability of selecting uh a black diamond. A black diamond. Black diamond. Diamond. Can anyone attempt to answer this one? What is the probability of selecting a black diamond from a deck of cards? Can anyone maybe answer that? You know. Okay. A black diamond. Do we have a black diamond here in this deck of cards? If you guys look, we remember we have black trees, black spades, but we don't have a black diamond. We only have red diamonds. So the probability will be 0 over 52. So essentially the probability is 0. You know, the probability of selecting a black diamond. Okay, maybe let's say another question, a probability of selecting a queen. A queen. All in all, how many queens do we have? It's one, two, three, four. So we have four queens. Four queens out of how many cards do we have in total? It's 52. So that will be 1 over 13. That's the probability of selecting a queen from a deck of cards. From a deck of cards, you know. So okay, maybe let's for the last one, we are asked to what is the probability of selecting a 4 or a 5? maybe to even draw some little spice there. Let's say a red 4 or black black 5, black 5. What is the probability of selecting a red 4 or a black 5? Let me write this one in red. Red 4 or a black 5. How many red 4s do we have? It's only this one and this one. We have two red 4s. And how many black 5s do we have? We have two black 5s. So that is essentially um all in all. So it's 2 plus 2, it's 4 over 50, 52. So it's still 1 over 13. That's the probability of selecting a red 4 or a black 5, or a black 5. Okay, let's say maybe a last one. Probability of selecting an ace, just any ace, or an eight. The ace or an eight. So how many aces do we have all in all? It's 1, 2, 3, 4. We have 4 aces. We have 4 aces, and then we also have 4 eights. We have 1, 2, 3, 4, 4 eights. So it's 4 plus 4. That will be 8 over. Okay. Now I don't like doing things like this because they can be confusing for some. Let's do, because someone would just think that we took this 8 from here and then we put it there. Let's do an ace or a 7, or a 7. How many sevens do we have? It's 1, 2, 3, 4. We have 4 sevens. We have 4 sevens. So it's gonna be 8 over 50, 52. So it's going to be 2 over 13 if we simplify that. So hopefully you guys are understanding what we're doing here. Probability is all about how much chance do we have of one thing happening over the other thing, over the other thing. So I think I've done a fair job in explaining that. If you guys have any questions before we move into Venn diagrams, you can ask them now. Then we shall move into Venn diagrams, and then yes, proceed with our lessons. I also want to do questions. I like doing questions because I think the best way to learn mathematics is to actually do mathematics. Venn diagrams. Venn diagrams. Venn diagrams. I'm sorry, guys. Something is happening. Can I please just take this call? I'll be back now. Okay. Thanks, guys. Someone was calling me. So just. Okay. So our next topic will be uh, a Venn diagram. So, whatever that we have talked about so far, the chances of one thing happening over another thing can be actually represented in a Venn diagram, in something else we call Venn diagram, and you will see uh, how those things work. So with a Venn diagram, we have something that is called the sample space. Sample space is essentially all possible outcomes. All possible outcomes. We just write that. That's for all possible outcomes, and then events we have events. Yes, and then yeah, then we deal with these things just sample space and events. The events can be, yeah, we just change there are a few things we need to know about the events. The events can be related, they can be mutually inclusive or mutually exclusive, and then they can be complementary. But without wasting any time, let's just go ahead and do an example uh, just to put that in picture, to sample space. Let's take that example that we're doing of numbers. So we can represent that uh, those two events of prime numbers and even numbers in a sample space. Let's say this is our sample space. It's 1, 2, 3, 4, 5, 6, 7, 8. I'm getting in eight again. Eight again. Eight again. Okay, it's fine. We said event A. Event A is let's say prime numbers, and then event B is what is even numbers. Even numbers. Even numbers 1, 3, 5, 7. Even numbers. Okay, maybe to spice things up, I'm thinking of doing odd numbers now. Of doing odd numbers. Let me see how that is gonna turn out. Let's just do odd numbers. You know, odd numbers. So, with the prime numbers, how many prime numbers do we have? It's 2, 3, 5, and 7. 2, 3, 5, and 7. It's 2, 3, 5, and 7. So it's four prime numbers. We can put that in a circle. It's 2, 3, 5, and 7. 2, 3, 5, and 7. What's happening? Okay. I think these events are gonna share a little bit too much. And then for odd numbers, we have 1, 3, 5, and 7. 1, 3, 5, and 7. So these two events have a lot in common. We can see here that these three numbers are common between these two events. So we can essentially represent this in a Venn diagram. Because we have some outcomes that are shared between these two events. So we draw that's not a cycle anymore. That's an egg. You know. Hey, hey. Oh, it's happening. Okay, these two events. So we said three of these numbers are shared. Let me just write the numbers in black now. We have 5, 3, 7. So the thing that we put there, right where I wrote those things here is the outcomes that are both present in both events, in both event A and B. In both event A and B. Here it's actually event A, A, and B. And this is how you even gonna write the probability of this, probability of event A and B. Probability of event A and B, it's what exists within that space, within that space. So all the outcomes that are actually common between the two events, we write them here. And here it's 5, 3, and 7. And then this was our event A, and this our event B. What is left here for event A is what is essentially 2. It's 2. It's 2, and then for event B, it's 1. That is not common. It's 1. And then remember that I say as we have a sample space. So a sample space will contain everything else that is not essentially that is not actually a part of these two events that are taking place that are taking place. Everything else will be contained in the sample space, So what do we have here? That is not that is not part of the events. So two, okay, it's one, two, three, five, seven. All of those are used, and then what goes into the sample space will be essentially is four. We will have four, six, and eight that goes into the sample space, to the sample space. So it's everything else that is not part of the event, that is not part of the event. Okay, so it can happen that these two events, um they are not sharing anything here. They are not sharing anything. No outcome is common between these two events, And when that happens, you will have a Venn diagram that is like this, you know, not connected. This is when two events do not share any outcome, do not share any outcome. So event A has their own outcomes, and then event B has their own outcomes. And then when that happens, we say we have a what? We have a mutually exclusive event, So this is a mutually exclusive, exclusive. Yeah, these two events are mutually exclusive, a mutually exclusive when they don't share uh, an outcome, And another thing that you need to know is exhaustive event. So for the exhaustive events is when all outcomes goes into the cycles, So all possible outcomes within, so nothing goes into the sample space for an exhaustive event, So all outcomes they go into what? Into the cycles, you know. Let me write that. All outcomes went into cycles, into cycles, you know. So this is when an event um is is exhaustive when all outcomes they go into cycles, so nothing will be there. So one thing that we can actually see about this that event A and B, we can see that therefore therefore uh, A and B, what we can deduce, from learning about mutually exclusive events is that A and B mutually exclusive. A and B are not mutually exclusive, not mutually exclusive, exclusive because they share some outcomes. They share some outcomes. They're not mutually exclusive. And again, uh, uh, we have some outcomes here in the sample space, which tells us that not all the outcomes went into the cycle. So I said P and P. What did I say here? A and P. So it's also not exhaustive. Exo exhaustive. And lastly, what you need to know is something we call complementary. 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 So events are complementary when they are mutually exclusive and exhaustive. So when everything goes into the cycles, and also uh, when no outcomes is shared, when no outcome is shared, that's when we say uh, an event is complementary. So it's both mutually exclusive exclusive, and and exo and exhaustive. That's when an event is complementary. And one thing about complementary events is that the probability of event A, probability of event A, probability of A plus probability of B is equal to 1. Is equal to 1. Uh that is for complementary events. That is for complementary events. I wanna write something else here. Something copy. Let me paste here. Talking about complementary event. Also, the probability, there is this other notation that you are going to learn. Probability of not A, probability of not A. So everything else apart from A. So that's how you write it. Probability of not A will be equal to probability of B. Will be equal to probability of B for the exclusive events. And then, sorry, for the complementary events. And then another thing that you should know about complementary events is that probability of A and B is equal to 0, is equal to 0, is equal to 0. Probability of A. Okay, I wanna say something. I wanna say something. Okay, and lastly, another thing that you need to know is this formula here. Is this formula? Just keep it in mind. You maybe some of you have already learned about it. Uh, have already learned about it. This formula, the O formula, um, which is probability of A plus probability of B minus probability of A and B, of A and B. Probability of A and B as the probability of A. Okay, probability of A or B. Just keep that formula in mind. Write it somewhere. It will come in handy in the near future. It will come in handy. Okay, so I think that is that with Venn diagrams. With Venn diagrams. I was kind of hoping to do a question just to cement what we did today. I know we still have to cover contingency tables and tree diagrams, but I don't want to overwhelm you guys with information. Okay, doing a wrong thing. Let me see if I have one question that maybe we can do that concerns um Venn diagrams. That concerns Venn diagram. Maybe drawing a Venn diagram. Okay, here this looks like it. Look like it. Okay. We just do one question and then this will be the end of this lesson. And then we will continue on. Okay. We'll continue on what's on Wednesday. On Wednesday with this. We'll continue on Wednesday with this. So I just wanna maybe draw event diagram, maybe answer just one question. And then yeah, we'll do more questions on Wednesday, because if I try to introduce contingency tables and then tree diagrams, I won't have time to do the questions, I won't have time to do the questions, so just overwhelm you with what you call this thing, I will just overwhelm you with information and not actually apply anything. So, a survey was conducted among 150 learners in grade 10 at Assassin High School to establish how many of them owned the following devices. So it's smartphone and tablet, smartphone or tablet. So already we can see that we have what? We have two events, and then among 150 learners, so we're given, let's say what? That's a sample space. That's a sample space. Let's draw our sample space. Uh, S is equal to 150 students, and then what were we given? Eight learners did not own either a smartphone or a tablet. So eight learners, they don't go into what? Into into either smartphone or tablet. So anything that do not go into the events, I said it goes where? It goes into the sample space. Let's write that down. 20 learners own both smartphone and a tablet. So here we can already see that this event is not what? Is not mutually exclusive, So we can go ahead and draw our circles now, because we have identified that this event is not actually mutually exclusive. So 20 learners. Remember, I said here it's both. So it's what? It's a smartphone here and it's a tablet here. 20 learners, they own both, 48 learners owned a tablet, 48 learners owned a tablet. So a lot of mistakes that students will make is that, okay, after seeing that, okay, 48 learners own the tablets, and then they just go ahead and write 48 here, which is actually incorrect, because uh, when we say uh, 48 learners own a tablet, we are essentially counting all of the learners, as you can see in that circle that I've just made red. Those are all of the learners who owned a tablet. It doesn't matter whether they own a smartphone or a tablet, but it's just 48 altogether. Altogether is 48. So essentially, we already know that out of that 48 learners who owns a tablet, 20 of them, 20 of them, they also own a smartphone. So how many are we left with? We are essentially left with 28 learners. 28 learners. And then what did they say? X learners owned a smartphone. Owned a smartphone. So we don't care if they own a smartphone and a tablet, but it's all of these learners in this blue circle that I've just made here. And we already know that 20 of those X learners, they also own a what? They also own a tablet, So out of those X learners, we're gonna say what? X minus 20. That is what goes in there. So basically your Venn diagram is done. You have answered question 7.2.1. And then we are now asked to find how many learners owned only a smartphone. That is your 7.2.2. 7.2.2. So right now we have to calculate how many learners own the smartphone. So we know that everything in the sample space should essentially equals to what? 150. So if we add everything in the sample space, it should be equal to 150. So we're just gonna solve for x now. So we say what? X minus 20 plus 20 plus 28, including that 8 is equal to 150, and then what do? We solve for x. 20 will cancel 20 here, and then it's 28 plus 28 is what? Is 36, and then we transpose 36 to the other side. X is equal to 150 minus 36, and then therefore x is equal to 150 minus 36. That will be, wait a minute, that will be 114. 114. How many learners owned only a smartphone or only a smartphone. So I almost made a mistake here. So I thought this was the final answer, X, but it's not the final answer because X, it's all of the learners that sorry, that owned a smartphone, it's all of those learners, but the learners who owned only a smartphone is this portion here because the out of these 114, out of these ex learners that owned a smartphone, 20 of them they own both. So here were us only a smartphone. So that's the trick of that question. So we have to actually proceed and say x minus 20. Wait. So only, let me say only smartphone, smartphone is equal to x minus 20. Is this one here, x minus 20. It's x minus 20, but we have already calculated our x is 114 minus 20, and therefore it's equal to 94. That's your final answer. That's your final answer. And then, so for 7.2.3, we're asked to calculate the probability. This one you guys can also do it because we have calculated everything. Owned only a smartphone. We already have that 94 there. 94 over what's the sample space is 150. 150. You can punch it in the calculator and get the answer. I don't have mine here, so I'll just leave it like this. You'll get the answer. Owned at most one type of a device. One type of a device. So on its most one type of a device. So it's either um owned one type of a device. It's either this simple it's either a smartphone and the tablet, or or the or the what you call this thing, or the tablet. At most one type of the device. So it's the probability of this out of 150, so it's essentially, let me see, owned at most one type of a device. So there's two ways we can actually calculate this. We can say the probability of a student not owning any type of device of which is 8 over 150, and then we subtract that from 1, or we can just add whatever we have here and then find the outcome. So 7, oh, that is your p, of which is the probability of only a smartphone. It's what we said, it's 94 over 150 plus probability of because so include for both smartphone and a tablet, of which is 20 over 150 plus, wait, okay, plus 28 over 150. Yes, I hope I'm not making a mistake here. So this is essentially gonna be what? It's gonna be at most, at most one type of a device. At most. No, they are saying at most. So we can't include that. Um, we can't include that 20 because that one owns two. That one owns two, so we can't include them. You know, at most. That one. So if it were, so I thought it was at least. If it was at least, we're gonna include everything. But since they are saying at most one type of a device, so it's 94. These are the students that own one type of a device, and here we have 28. over 150. 28 over 150. Let's see. Uh, to establish how many of them own the following devices. So we don't know. I'm not sure about this 8 here, because this one they could have other devices, that are not included here. But for the sake of this one, we're just gonna assume that they don't have any device at all, you know. So here we can essentially have two answers, So 94 and 28, you simply add that, and then that would be your probability. You can calculate that with your answer. And then another outcome that is possible. So if we assume that these eight here in the sample space, they do uh, own a device, but it's just not this smartphone or tablets, and then the probability will be, maybe let me write this in red, 94 over 150 plus 28, 28 over 150 plus 8 over 150, and then you find the answer. If we assume that those 8 students, they actually uh, own a device, just not a smartphone or a tablet. Okay, thank you guys for joining today's session. This marks the end of our lesson today. Thank you so much for joining. We're gonna have another lesson on Wednesday. We're gonna do three diagrams and contingency tables. I'll just try to do a quick revision of what we did today, and then we're gonna go over as many questions as we can, because I think the best way to learn mathematics is to actually do mathematics. I heard that some of you are actually writing. All the best with your test tomorrow. Yeah, until we see each other again. I wish you nothing but all the best. But good luck. Yes. Thank you.